A warm welcome to this webinar. The topic of today's is digital manufacturing, how we can increase the productivity and increase the bottom line using the digital technology. So, uh, right. So today's topic is Industry 4.0. This Industry 4.0 is basically is considered as fourth revolution of industry, which will be revolutionized using the data. I mean, we'll discuss about these things in the course of our presentation. But the main agenda of today's seminar is that how we can increase the productivity, right? I mean, and the profitability of our manufacturing plant. I start with a small story about Karoli Chakas. He was a national champion of Hungary. I mean, he was a big shooter, and during this his career, like I mean, he has been throughout national champion, and it was dated in 1938, and 1940 में एक Olympic होना था, and he was preparing for that. Uh, Everybody knew he's the guy who will win the Olympic medal for Hungary, but he was in army as well. So I mean, one day, I mean, he was practicing in army, और उसका accident हुआ and he lost his dominant hand, which was his right hand, and that was a setback actually. And but he did not give up. What he did is he practiced with his left hand, which was not dominant. He could not even write with that hand. So once he practiced and he was preparing very well, and then he was targeting for 1940 Olympic Games. But because of World War II, the Olympic game was postponed. He was devastated कि अभी तो इतना तैयारी किया again. Like I mean, when he was on top of his pinnacle of his career, again he got another setback. Then he started preparing for 1944 Olympic game. Then again the Olympic game was postponed because of World War. Then he prepared for 1948. At that time, his age was, I mean, from 1938 to 1948, another 10 years. And it was very difficult to compete with youngsters. But he did not give up. He prepared and he won the Olympic gold medal. Doesn't it sound a similar situation as we are in right now? So, I mean, this is an inspirational story. I mean, I just wanted to share. So, I mean, coincidentally, we are seeing the Olympics also getting postponed this year as well. Right. So, this is about the speaker. That is me. My name is Manish Chen. By qualification, I am an electrical engineer. Did electrical engineering honors, and then I did my post graduation in instrumentation. I'm a certified energy manager from Bureau of Energy Efficiency. Digitalization is my passion and my my interest. Right now, I mean, we are developing some solutions which involves industrial IoT. Before starting my career as an entrepreneur, I have worked with companies like ABB Corporate Research Center, Infosys, Infineon, Raymarine. These were the companies which I worked for. Globally, I got an opportunity to work in Germany, Sweden, and the UK, and of course India. So before I started my career as an entrepreneur, I have been involved in designing solutions for automotives, industrial automation, marine navigation, and energy sector. So since I come from engineering background as well as the IT, so I mean I had a good opportunity to learn various things from a different angle. So in current my career, like I have founded 3 companies: Feliday Systems, PM Electronics, and Power Profit Technologies. Feliday Systems is into industrial automation, and PM Electronics is into machines, where we are providing high-end machines for manufacturing. And Power Profit Technologies is completely dedicated for new age solutions, which we are going to talk about. So before we move on, let's have one quick poll that just like the kind of industries we are from. So can you see the poll? So the type of industries, tier X, I mean, I've included tier 1, tier 2 manufacturers who are supplying for, higher grade tiers and OEMs. B2G is business to government, and B2C is business to consumer, and equipment manufacturers or the solution manufacturers who are providing, equipments like machines or some kind of solutions, or paint shop, etc. I can see some more guys are joining now. So for who are joining now, we are just conducting a quick poll, जिसमें आपको ये मेंशन करना है कि आपका इंडस्ट्री टाइप क्या है. आर यू फ्रॉम टियर 1-2 मैन्युफैक्चरर जो कि OEMs को सप्लाई कर रहे हैं. आपका बिजनेस क्या है, बिजनेस टू गवर्नमेंट और बिजनेस टू कंज्यूमर्स और इक्विपमेंट मैन्युफैक्चरर और द सॉल्यूशन प्रोवाइडर्स. During this webinar, please feel free to raise your question as and when you have. I would like to make it more interactive. All right, we have got the poll. Let's finish the poll. Another 5 seconds. 5, 4, 3, 2, 1. Go. So here's the result. We have pretty much almost balanced type of, I mean, of course, business to government suppliers are the least, but tier 1-2 manufacturers and business to consumer and equipment manufacturers. I mean, okay, so we have got most of people who coming from machines and equipment background. So let me just check. Right. Okay. Good. So I have got fair idea about our audiences. Right. So let me just start with the story about Industrial Revolution. We have read in history that Industrial Revolution happened once. Mr. James Watt invented steam engine. उन्होंने steam engine का invention किया. उसके बाद उससे पहले सब लोग जो है ना, like weavers, potters, और जो like shoemakers, they were, I mean, they were working from house, right? So they were manufacturing, and they were the manufacturing houses basically. Once the steam engine was invented, this machines were developed so that major textile machines, major metal processing things could have been done using the machine. I mean, because of the force of steam. And then in 1870, once we were manufacturing, big cloth companies were there, big sheet metal companies were there, but still further, customized solutions were required. For that, the problem was that the line which was dedicated for one type of product, if we have to produce another product, another line had to be set up. So 1870 में Mr. Ford invented with the concept of assembly line, जिसमें कि you can customize the product with different type of solution. And here in the assembly line, each individual worker was dedicated for one particular type of task. So as a result, the productivity increased manifold, and variety of products were increased, and time to market was reduced drastically. So that was another revolution, and it was started in car manufacturing. Uske baad, we can see in garment industry or any type of industry. I mean, assembly line is a core manufacturing practice. And in 1969, again another revolution came when this automation happened using computers and electronics. Robots were invented. Most of the control part was through the electronics and the software side. So we have seen from 1969 till now, we have seen this industrial development through controllers like PLCs, DCS, all these type of controls are there through which we are manufacturing the product. Now, this Industry 4.0 is the latest revolution. In the history, we have not seen that during that revolution or before that revolution, anybody declared that it was Industry 2.0, 3.0, 1.0. By nature, we are declaring it is a 4.0. So by nature, it is a predictive type of standard. We are predicting that it's going to be a revolution, and what is causing that revolution is the data. So now we are seeing that 10 years back, smartphone was is a special position for anyone. But nowadays the penetration of smartphone is so much. Everybody's aspiration level has gone up. Everybody wants everything on his smartphone. So in last 10-15 years, we have seen drastic change in the human behavior, and that's what we have seen in our day-to-day life. Our entire banking, our retail shopping, everything has come to your mobile phone, right? Nowadays we are seeing movies also through Netflix. It's also customized. So it's up to you, can customize what you want and when you want. So it's up to that level. So in industrial revolution also, everything will be based on data. So everybody will be talking about in industries, machines will be talking to each other, and it will be so distributed that one part could have been manufacturing here, or it could be like what we have started from in 1784, that people were working from home. Now we are seeing the same thing. We are seeing people are working from home, right? So the complete circle is there, but with a great leap. We'll discuss this Industry 4.0 in detail. So the soul of this new revolution of industry is the data. So data is everywhere, right? We see data, and this is a new term, like data is new oil. Since oil is very prestigious thing, and everybody want all big countries, they want ownership of oil refineries as much as possible. So once we say this data is new oil, it is not just because of the value of the oil. It is because of two things. एक तो oil बहुत important है. जैसे पहले बोलते थे कि oil is new gold. Now data is new oil, so that means data is gold. But data, we cannot say it's gold, because gold has just one value, but oil has multiple values. जैसे oil, आपने crude oil लिया, you get refinery. You get refined oil for planes, which is highest form of oil. Then we get petrol, slightly lower value. Uske baad diesel, paraffin, kerosene oil, and then charcoal. So even the single bit of the oil is not wasted. complete plastic industry is dependent on oil extraction, right? So we see oil is so useful. We get very good quality product as well as the least quality product. So same is the case with the data. Once you have data, we can extract very valuable information which you can use for increasing your profitability, as well as you can extract some information which will be helpful for getting the low hanging fruits. So why do I need it? As a manufacturer, we know that, I mean, data is obviously is important. We see everybody is talking about data. Facebook is talking about data. WhatsApp is talking about data. Google is completely a data company, right? But for manufacturer, why do I need it? Uh, First of all, for any manufacturing unit, investors feel confident with automated data or information. So if you have any report, or if you have systems which show that all of your data, the production data, your quality data, your all I mean, shop floor to top floor integration is there. I mean, the data flowing from shop floor, it's a real data which is going into the your ERP system. So your investors, your bankers, your shareholders, they will feel confident, and they rely on this data. Believe me, this is very important aspect. And for tier X manufacturer, your OEM loves automated information. We know all that. I mean, they have been talking about as much as information so that they can implement just in time. They can implement low rejection and traceability. So उनको डेटा चाहिए ही चाहिए. अगर आपने implement किया, they will love you. So for providing as much as information you can do. For B2C, I mean, B2C के लिए थोड़ा सा उनको ये लगता है कि ये जो डेटा है इसका हमारे लिए तो कोई पूछने वाला नहीं है. But B2C is that some of your process data is very important when you are showcasing it for dealers, for your consumers. I mean, people are so that your dealers will have more confident on your product. They will sell the product with more confidence. And consumers, we have seen in so many of commercial advertisements, they show that you can fetch information of that product from your web and all that thing. So this is just to give your consumer a great sense of confidence. Equipment manufacturer, customers want a connected device solution. So if you are an equipment or solution provider, your customer wants that connected device. So if you are supplying any machine or any equipment, they want it to be integratable with their existing system. And more and more this awareness is coming. So the one who's providing data oriented solution, they will have an edge over the others. And overall, every industry needs data or information for increasing the bottom line. I mean, top 4 benefits which I discussed is for your customers or for your consumers, right? But for improving your own internal processes, you need data so that you can reduce your losses. So this is a slide. I mean, these are the big names of industries as of now. Google, Facebook, Uber, WhatsApp, Amazon, Alibaba, Airbnb. One thing is common in all these big companies. That is, they don't have any inventory. They don't have any manufacturing plant. What they have is just data and the data centers. Of course, वो हमारा data को use कर रहे हैं. That is another thing. But still, I mean, they are just playing with the data and they are getting some information which is helpful for the advertisers. So sooner or later, we have to realize that we have to go into the data-oriented way so that we can also find out where the loopholes are, how we can increase the productivity, or how we can have another revenue section. So for example, some compressor manufacturers, they have started providing compressors as a service. I mean, as a subscription-based compressors. So their compressors are giving the information how many hours this compressor has run. So they are just charging rent on that. So there are new, business models which are evolving over the period, right? So once if you are an equipment manufacturer, you can sell that equipment with certain margins. But if you provide this type of your equipment or the services along with that, you can sell your solution as a subscription. So that will be a perpetual revenue model, right? It's not one of type of revenue. So there are new opportunities which are coming. So we have to identify which one suits our model the best. So I'm not talking about the new challenges only, but of course, I see it as an opportunity. But recently, the biggest challenge which we are seeing is COVID-19. So what we are seeing is COVID-19, and how we are dealing it with that is, of course, data. So we are analyzing कि कितना हमारा curve flat हो गया है. Is it on the increasing side or is it on the decreasing side, right? So we are getting information, local based information, identifying the red zone, green zone, orange zones, right? So it's all based on data. The fight with this COVID-19 is complete in the data. So अभी आप देखेंगे there are hundreds of sites which are showing COVID-19 data in a different way. So pictorially they may show it differently, but the idea behind is to make you aware about how this COVID is getting spread, so that you can protect yourself. So so far is there any question before we go ahead? Let me just check. Okay. Mr. Siddharth Singhal says, regularly breaking audio and video. I'm so sorry. I hope that now it should be stable. Right. So please stop me in between if you have any question. The problem with this platform is that when I'm seeing the slide, I won't be able to see the chat window. So I will take some breaks, and then only I will be able to see the. Okay. Thanks, Mr. Singhal. Thank you. So we'll go with our right. Okay. So industry 4.0 for manufacturing, it's an holistic way. It's not just for one side of development. This will be helpful not only for your customer but for your internal processes as well. So when we are talking about industry 4.0, the technologies which are there, we won't be touching all the technologies, but just to give you an idea, जो technology है, everything which is data driven, that is a technology for which is used in the industry 4.0. On top of that, you can see this virtual reality, or we call it as augmented reality. जो लोग maintenance में है या who are providing the services for their equipment, the trend is that a semi-skilled or unskilled person will go on the site, and highly skilled person he will support remotely. Now if you see the beauty of this technology is that if a highly skilled person needs to travel, so the traveling time which he will incur, that will be a waste. So अगर वो अपने office में बैठा है, and he from there he can serve 10 customers at the same time, right? But अगर वो उसको, if he has to go to field, so he will have a limited service scope. So that's how especially the equipment manufacturers, they are providing services to their customers. The second one is manufacturing by data. 3D manufacturing is picking up in recent past. We have seen 3D manufacturing in prototyping, which is very successful. आपका अगर कोई प्रोडक्ट बना रहे हो तो आप प्रोटोटाइपिंग के लिए everybody is going for 3D printing. So this 3D printing, but the technology is maturing so fast. In maybe in another 3-4 years or 5 years, or maybe very soon, we may see that small parts are getting manufactured in the 3D printer only for normal use. I mean, कुछ एक parts अभी भी start हो गए हैं, but we can see that once, I mean, this will be a customized type of manufacturing plant, जिसमें लोग अपना एक manufacturing unit एक 1000 square feet के plot में अपना open कर सकते हैं, and then they will start manufacturing anything. And artificial intelligence, this is when once you have data, you get the information and you can take decision based on the data which you have collected. So that involves the predictive maintenance of your machines, the quality parameters of your machines or plants, and there are so many things through artificial intelligence you can get. So now the question is, we know data is very important, but how to identify the right data? हमारे प्लांट में हमारे पास इतनी सारी प्रोसेसेस हैं, हमारे पास इतना सारा मैन्युफैक्चरिंग इंफॉर्मेशन है, बट हमें ये नहीं पता कि उसको कैसे लेना है. तो सबसे पहले तो क्या है कि हमें अपने जो भी आपकी मैन्युफैक्चरिंग प्रोसेस हैं उसमें से आइडेंटिफाई कीजिए कि आपका हिडन डेटा कहाँ पर है. हर एक मैन्युफैक्चरिंग यूनिट में, हर एक प्रोडक्शन प्लांट में एक सर्विस का एलिमेंट है, राइट? I mean, if not in the manufacturing, but in your business side. So अगर आपका कोई भी चीज जो आप सर्विस में डाल सकते हैं, राइट, और वो आपका सर्विसेबल जो पार्ट है. फॉर एग्जांपल, I just give you an example about the compressor, right? कंप्रेसर मैन्युफैक्चरर ने देखा कि एक सर्विस एलिमेंट उनका क्या है कि दे हैव टू गिव द एएमसी. तो उन्होंने उसी पार्ट को एएमसी का जब डेटा कलेक्ट करना शुरू किया, then they realized कि जो उनके कस्टमर्स हैं, they are happy to pay on the subscription basis, जिसको हम क्या बोलते हैं ओपेक्स मॉडल में. तो ओपेक्स मॉडल में क्या है कि उनके लिए if they have to take decision in the capex model, उसके लिए बड़ा लंबा एक प्रोसेस बन जाता है उनके लिए कैपिटल मशीन्स को परचेज करने का. एंड स्पेशली फॉर गुड क्वालिटी मैन्युफैक्चरर्स जिनका प्राइस बैंड ज्यादा होता था, एंड दे फाउंड इट वेरी डिफिकल्ट टू पिच इन कॉस्ट कॉम्पिटिटिव मार्केट एज इन इंडिया. सो उनके लिए एक चैलेंज होता था कि भाई उनको हम कैसे जस्टिफाई करें, बिकॉज परचेज पीपल का उनका टारगेट ही होता है कि भाई टू बाय द इक्विपमेंट एज चीपर एज पॉसिबल. उन्होंने वो डेटा कलेक्ट करना शुरू किया. दे स्टार्टेड कैलकुलेटिंग कि हमारा एएमसी का कॉस्ट क्या है, हमारा कैपिटल कॉस्ट क्या है, उसमें हम कितना मार्जिन ले रहे हैं. एंड फ्रॉम देयर दे फाउंड अनदर बिजनेस मॉडल, जो कि नाउ new equipment manufacturer who has completely changed his business model into service model, right? So once we start finding कि हमारा वो service model का वो element क्या है, then we can get the data right. And second thing is very important कि हम जो data ले रहे हैं, can it be automated? जो manual data collection है, this is always prone to error, manipulation, and inaccuracies. I mean, inaccuracy means it's not just because of the value of the data. It's about when the data was taken, which is very important. क्योंकि data का जो importance है केवल value से नहीं है, जिस time वो लिया गया है, that is very very crucial. Please keep it in mind. So अगर आपके पास automated है, the timestamp of the data collected is stored along with the data value, so that data, the information actually, the information which you'll get from the data will be accurate. I mean, it's the same thing like is the data collection in real time. The real time data is slightly different from inaccuracy of the data time taken. It's about the real time information when as and when it is happening. अगर आपके पास फॉर एग्जांपल आपके पास टाइम स्टैम्प के साथ डेटा आ गया कि आपके प्लांट का पावर कंजम्पशन कैसा था, राइट? तो आपके पास ये जो डेटा है एंड ऑफ द डे आया, बट आपके पास अगर वो रियल टाइम में इंफॉर्मेशन होता, तो अगर इफ समथिंग गोज इज समथिंग रॉन्ग इज हैपनिंग, राइट, यू कैन गेट इट राइट देन एंड देयर। अगर आपके पास रियल टाइम डेटा नहीं है तो द आई मीन दिस इज स्टिल यूजफुल, बट इट विल बी मोर यूजफुल इफ यू कैन मेक इट रियल टाइम। तो इज द डेटा बिहेवियर रिपीटेबल? सो अगर आपके पास कुछ डेटा है जो कि आप एक सर्टेन certain pattern, if you can see, this is very 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 useful for especially for making some decision as well as the predictive analysis. So what I would suggest is go and start segregating your process, each and every process. वहां से आप देखिए कि कौन कौन सी इंफॉर्मेशन है जो ए प्रोसेस से दूसरी प्रोसेस में जा रही है, और आप इस प्रोसेस को जितना माइन्यूटली आप ब्रेक करेंगे, यू विल गेट दैट इंफॉर्मेशन। आपको पता चलेगा कि एक प्रोसेस की सब प्रोसेसेस होंगी, और उन प्रोसेस सब प्रोसेस में कम्युनिकेशन हो रहा होगा बिकॉज ऑफ डेटा। सो यू हैव टू एक्सट्रैक्ट दैट डेटा। अगर if you have any question for any type of process, please feel free. I mean, we can have a one-to-one session offline as well. So profitability is very interesting concept. Profitability is, of course, I mean, is dependent on two factors: cost and revenue. So जो कॉस्ट पार्ट है दैट इज इन आवर कंट्रोल, रेवेन्यू इज समथिंग विच इज मार्केट ड्रिवन। तो अगर आपके कस्टमर ने या आपके कॉम्पिटिटर ने, इफ ही हैज सेट सर्टेन वैल्यू ऑफ द प्रोडक्ट ऑफ योर कॉम्पिटिशन, राइट, तो आप उससे ज्यादा नहीं बेच सकते हैं। सेम इज द केस विद योर ओईएम, राइट। ओईएम को पता है कि आपका क्या कॉस्ट है, एंड ही डिसाइड्स द कॉस्ट ऑफ योर प्रोडक्ट। But if you are in a scenario when cost is getting increased, revenue is not increased that much, so you are in loss definitely, right? अगर आपने revenue बढ़ाया and cost थोड़ा सा कम बढ़ा है, so that means you are doing some positive impact, right? I mean, या तो आप नया product develop कर रहे हैं जिससे कि आपका revenue stream बढ़ रहा है, which is good, right? But in current scenario when the revenues are stagnant, हमें पता है कि हमने जो प्रोडक्ट का प्राइस सेट किया है, it's not going to be increased. What we have to focus in the is the cost. So अगर हमारा cost reduce हो जाता है, तो and if we even if we are having a stagnant revenue, the profitability will be increased. So cost को reduce करने के लिए क्या है, आपको अपनी process को optimize कर सकते हैं. You can produce more in a certain time. You can reduce the losses, you can reduce the rejection, and of course the fixed costs like energy and water, these are the process parameters which you can work on. So let's have another poll here. So what is your biggest oh sorry. Right. So here in this poll, प्लीज जस्ट मेंशन व्हाट इज योर बिगेस्ट कॉस्ट फैक्टर, जिस जो आपको लगता है कि जिस पे आपको वर्कआउट करना होगा, जहाँ पे हम जब सबसे ज्यादा कॉस्ट इनकर हो रहा है, अगर हम उसमें रिड्यूस कर सकते हैं, वी कैन इंक्रीज द प्रॉफिटेबिलिटी. In the meantime, I'll just check. So, Uh, we have got a question from Mr. Keshav Bhatia. Mr. Bhatia, I would request, I mean, not, I mean, for from everyone, अगर आपका कोई भी क्वेश्चन है आप पब्लिक मोड में डालिएगा, सो दैट बाकी जो व्यूअर्स हैं उनको भी एक बेनिफिट हो सके. तो उनका क्वेश्चन है, being an MSME, kindly elaborate what help can we get in getting work done from automation, which is need of our, as because of COVID-19, keeping distance factor in mind. भाटिया जी, इसमें क्या है कि हमारे पास मतलब जो ऑटोमाइजेशन है, देर आर टू टाइप ऑफ ऑटोमाइजेशन. एक तो आपका प्रोसेस स्पेसिफिक है कि प्रोसेस में आपके कहाँ कहाँ पे पॉसिबिलिटी है, ठीक है. और उससे पहले अगर आपका कोई भी डेटा मतलब जो ऑटोमाइजेशन है, व्हाट वी वुड सजेस्ट इज कि आप जो अभी मैंने पिछली स्लाइड में बताया कि आप पहले एक अपना एक चार्ट बनाइए, अपनी प्रोसेस को बनाइए कि जहाँ पे आपको लगता है कि आपकी प्रोसेस का सबसे ज्यादा टाइम कहाँ पे कंज्यूम हो रहा है या मैन पावर जहाँ पे कंज्यूम हो रहा है, ठीक है. और उसके हिसाब से, क्योंकि अभी क्या है, पहले के सिनेरियो और अभी का सिनेरियो में बहुत डिफरेंस हो गया है. अभी हमारा सिनेरियो जो है ना, जो आपने करेक्टली मेंशन किया है, कोविड-19 में हमें सोशल डिस्टेंसिंग भी मेंटेन करनी है, और उस सोशल डिस्टेंसिंग को मेंटेन करते हुए हम कैसे कर सकते हैं, दैट इज अ की फैक्टर. तो आपको अभी जो अपने डेटा को आइडेंटिफाई करना पड़ेगा इन टर्म्स ऑफ द टाइम इन मैन्युफैक्चरिंग फॉर दैट पर्टिकुलर प्रोसेस, एज वेल एज जो आपका मैन पावर यूज्ड. तो आपको अगर जो वो डिस्टेंस का ही मेंटेन करना है, या आपको, अच्छा इसमें एक और चीज होता है कि आपको डिसाइड भी करना पड़ेगा, बिकॉज अभी इनिशियली वी विल सी कि आपके पास मैन पावर का भी एक शॉर्टेज होने का एक पॉसिबिलिटी है. ऑफ कोर्स, आई मीन नॉट जस्ट बिकॉज कि वो माइग्रेंट लेबर चली गई है. एक चैलेंज ये भी है कि हमारे पास जो डिस्टेंस मेंटेन करनी है, हम वी कैन नॉट एकोमोडेट मोर पीपल, तो हमें वो वी हैव टू रिड्यूस. तो पहला तो सबसे पहला काम ये रहेगा कि आप, आई वुड सजेस्ट कि आप अपना सेल्स पे टारगेट कीजिए. जो आपका प्रॉफिटेबल है उसको आप निकालिए, उसको आप मैन्युफैक्चरिंग में डालिए, एंड देन वी कैन जस्ट सी कि हमारे पास उन प्रोसेस में हम कहाँ कहाँ पर उसको आइडेंटिफाई कर सकते हैं ऑटोमेशन का. तो जैसे अगर जो फिजिकल ऑटोमेशन की बात करूं, जिसमें मैकेनिकल, रोबोटिक एंड ऑल, वो कंप्लीटली डिपेंड करता है कि आपकी प्रोसेस कैसी है, उसमें सॉल्यूशंस हैं. वी हैव टू वर्क आउट व्हाट दीज सॉल्यूशंस आरओआई आर, ठीक है. तो अगर हमने बहुत महंगा ले लिया और हमारा आरओआई नहीं आ रहा है, उसका कोई बेनिफिट नहीं होगा. तो हमें अभी आरओआई की कैलकुलेशन भी डिफरेंट हो जाएंगी अभी. सो आई वुड सजेस्ट कि आप उसे एक एटलीस्ट स्टार्ट मेकिंग एन एक्सेल शीट. उससे कुछ हमारे पास जब डेटा आएगा, देन ओनली वी कैन टेक बेटर कॉल. राइट. ओके, सो fine. So here is the result. 27% people think that the energy cost is highest. Employee cost is 42% people think, and 29% is the quality cost. Okay, so with the help of industry 4.0 automation, definitely we can reduce this cost of energy, employee, and quality. So okay, so let me just go to the next slide. Okay, so just to set the context, what exactly is the industry 4.0 and how it is applied in industry, especially manufacturing industry. Here you can see a person who is he's an athlete. uh, he jogs every day, he comes back, his performance is just based on like how many hours or how many minutes it took him to complete a marathon, right? But he wears a smart band. After that, what he gets is information about himself. What is his heart rate, what is the blood oxygen, what is the blood pressure. उससे क्या हुआ कि he gets all that information when he was running, what type of his body response was, right? So based on that, he can optimize his workout, he can optimize his diet, he can optimize his performance, and he can be a better athlete in a shorter time. So if we think in the similar way, this industry 4.0 works exactly the same way. We have machines, and the moment we put some kind of sensors or we pull some information, we get information about the health of the machine, the productivity rate, the breakdown information, the power consumption, expected delivery, total wastage. So we can plan our delivery time, we can plan our maintenance time, we can check how much is the energy consumed, and what is the productivity, what is the major cause of breakdowns. So once we start collecting that data, we can optimize, we can make ourselves leaner and faster and more efficient. So in industrial unit, these are the major sections, right? Uh, Production, maintenance, and engineering and quality. So production people, I mean, they just need to focus on the manufacturing, how optimizely they can manufacture. Maintenance uh, is a cost center, uh, which does not earn revenue, right? Everybody sees maintenance as a cost center. So the more we can reduce the cost, the pressure is on the maintenance. Uh, of course, when their another job is to keep machines and the production keep running. So entire utility is their responsibility, but the one key factor which is the responsibility of maintenance team is the energy. Uh, in any plant, the energy has majorly three forms. One is the electrical energy, which is again be sourced using your distribution companies, discoms, your solar. I mean, nowadays there's renewable energy sources, your alternative energy sources like DGs. So each of these source of energies have different uh, characteristic, right? From discom, you have to focus on the penalties if they are incurring, like for example for power factor, for maximum demand cross, and for nowadays certain utilities are charging for uh, harmonic distortions. So we have to look into this. And from another source of energy like DG, we have to focus on the maintenance of the your alternating source of power, and how much what is the optimal level of your genset, so that you can either you can implement load management system with multiple DGs synchronized with each other, or the solar is entirely a different game altogether. It is completely a capital intensive. So if you plan to go for solar, you have to look into the ROI. If you are getting ROI faster, please do that. You can export power. Of course, I mean, it is not meant for 24 hours supply, but during your peak time, if you have ample space, you can go for that. But the requirement for the maintenance team is to reduce the cost of energy. So in that case, what they have to do is they have to identify the energy in from two domain. One is from the supply side, another is the consumer side. Consumers are internal consumers, so they have to see each machines, each shop floor, how much energy they are consuming, and the quality of power they are getting, so that they can manage it very well. And other source of energy is in industry is compressed air. Of course, I mean, this is a converted uh, energy which is converted from electrical to compressed air. But compressors by nature are very inefficient machines. uh, we have to see, I mean, if we are seeing that the leakages are more, so we have to maintain in a way, we have to monitor the consumption of the compressed air, so that the leakages can be reduced, and we can plan operation of compressors, so that the cost of electricity will be less. The third one is I mean, in case of energy is the boiler. Boiler is similar to compressor, जिसमें हमें we have to see how much fuel is consumed in generating the steam. The other thing is what they have to look into this maintenance thing is MTBF, uh, meantime before failure, and MTTR, meantime to repair. So these are the key factors which shows that how efficient your maintenance process is. So we have to reduce these two parts, and which will require, preventive maintenance, which is being used in many of the plants. But apart from preventive maintenance, we have to go for predictive maintenance. So we will discuss how we can implement this predictive maintenance in Industry 4.0. So, and MTBF is very important, and how we can fetch that information from the machine for failure information. Maintenance management system, it's a entirely different product, or the solution, but which is key, not just for the running the maintenance, attending the calls of the user, but also for your inventory management as well. So your key maintenance part, so it should be in just in time. So key part should not be more in number or less in numbers. So you should have enough inventory of your uh, maintenance, spare parts. Predictive maintenance, as I said, that MTTR, or to reduce the MTTR and MTBF, this predictive maintenance is very important. So as we have been doing reactive maintenance, as and when some breakdown happens, we are doing maintenance. Then we have started doing preventive maintenance. It's a scheduled type of maintenance which maintenance department has to do on the off days. And predictive maintenance is that before even the downtime, the breakdown happens, so we can maintain our machines. From production point of view, here I just want to give you an analogy. Since I'm an electrical engineer, I would give in analogy of electrical engineering. Even if you don't understand, plus please just bear with me. In electrical engineering, the idea of entire electrical power system, how big is it is, or the power grid, or the small motors, or anything, there are only two parameters on which entire electrical engineering is dependent. The two parameters are voltage and current. So voltage is something which is supplied to you. Current is based on your load, how much you want to draw. So based on these two parameters, the entire electrical engineering works, right? So they get information about the power, they get information about the energy, they get information about the short circuit, or any type of failure, or any protection. Everything is based on these two factors. So once we go into deep of any process or any type of engineering, we see there are some critical, some key parameters, and using that we can get any type of information for your process. So for example, in case of machine, right, for any particular machine or any production line, so we get information about the running status, whether this line or the machine is running. The production count, of course, it depends upon the discrete manufacturing or the bulk manufacturing. In case of discrete manufacturing, for example, injection molding machine, as and when the injection happens, so that means one particular piece of product is manufactured. But in case of regular production, for example, textile, paper, or wire, we see we can measure the length of the cloth, the garment produced, or the sheet metal, or the paper produced, based on the kind the what you call the area of the that product produced. Uske liye, like, we have encoders, so from there we get the information, the production count. And the rejection is very important, especially for quality. Rejection gives you information about what type of rejection it is that. right? So once you start collecting information about the rejection, so everything is there in the I mean from the machine side. So how we collect is, I mean, either the inspection is manual or automated. In both the cases, as and when the piece is produced, if we register that information, we get huge amount of information about your quality. And breakdown is how we can reduce the breakdowns. We have to identify what type of breakdown. So if suppose the running status goes low, that means, I mean, if it is the machine is not running, uh, after certain time it will be in breakdown, it will be declared as a breakdown. So what was the cause of breakdown, we have to identify. And two things what we have to find out is like how frequent that particular breakdown is happening, and for how long this breakdown is happening. Now this breakdown is an important, which is important factor for calculating this MTBF and MTTR, right? So based on these information, and these all are information, these all information are all available on the machine side. So either in fully automated way or semi-automated way, we can fetch these information from the machine. And for quality assurance purpose, uh, like as I said, this rejection count. Once we start getting this rejection count, we can fetch the information. What was the major cause of rejection? Uh, Based on that, we can work out for the process why that particular rejection is happening, and we can increase our, the quality of the product. Traceability is very important nowadays. We have seen in automotive and pharma sector, traceability, like I mean, if you have produced certain product, right, we should know what was the reason for that fault in the product, and was it because of some supplier or from the vendor side. So if we have a traceability of that particular product, who was the supplier, and what serial number was having what parameter of testing, etc. So it's a complete science, I mean, complete engineering, which we have to do. And there is no limit for kind of traceability we can implement. We can implement traceability of the quality test parameters, as well as traceability of the manufacturer, the supplier of that product, the traceability of the operator, the traceability of the line number or the machine number, traceability of the date and time of production, everything. So if we find anything similar in certain type of failure, so we can identify that this particular lot is could be a faulty load. Faulty lots, and we can do some kind of recall, or we can do some kind of advisory that for our customers for certain type of for certain lot of product. Statistical process analysis is, I mean, industries do a lot of analysis on quality. Now the problem with this type of is that most of the data uh, are distributed in an industry. I'm talking about, for example, in automotive or automotive related industry. So every section has their own, testing and quality machines, right? So they do record all that information, but these are all distributed. So we cannot, I mean, at the end of the day, or at the end of the shift, what we do is like we collect that information and we analyze what was the quality parameter of for that particular machine. So if all of these machines or the quality test are integrated, it is very essential, very important that we collect that information in real time and a centralized location, centralized place. This particular graph shows, the bell curve of quality, which is widely used in Six Sigma. Like, I mean, the deviation of the product parameter. For example, in assembly line, the tightening parameter, at what torque you are tightening the bolt, right? So this has to be logged, and how much variation was there. Similarly, in case of electronic manufacturing, your source of components are same, but still, I mean, if you are seeing some variation in your product energy consumption, or your, for example, the lumens in your bulb or anything. So we can just see what was causing that deviation. So the reduced deviation means the increase the quality of the product. So uh, in industry, how it is being done as of now is, people collect that data, import that data in Minitab or similar type of tool, and generate reports, which are not in real time. So if we start collecting that data, make it central, we can collect that information, and if there is any error happening from a central place, we can just see and we can stop the process. It may be possible that one particular quality compromise is happening because of the uh, previous process. So by that time this is getting produced, I mean the raw material is supplied to the next process, so we will not be able to correct the previous process. So the more we get information in centralized place or in real time, we can control the process faster and easier way. Uh, Now, this is an very familiar equipment effectiveness model in industry. Mm, I mean, especially who have implemented lean, they have implemented this equipment effectiveness, availability of your machine, the performance, and the quality. These three are the key parameter for optimizing your processes, right? And if you can have availability of your machines as much as possible, that means your machine is available for you to manufacture more. The performance is completely manpower or the process dependent. If there are certain type of minor stoppages, your performance of the productivity will be reduced. Quality, again, there are multiple reasons. And if you want to produce zero defect product, so you have to reduce the rejection. And one parameter is very important here is the energy. So if we work out for OEE model, I mean, we call it as OEEE, not OEE. Energy is a key factor because that's a cost. And we would recommend that we should calculate the cost of energy in each piece you are producing, or each meter of the product which you are producing on a shift basis. So, in case of real-time monitoring, I mean, now this is about the domain of manufacturing, how it happens in the technological domain. From IT point of view, now one term which I think I'm sure, I mean, everyone must have heard is IoT, Internet of Things. So we have been using internet for communication purpose for our day-to-day working, our banking, shopping, etc. But now this technology will go into the next domain, that is a things domain, where we see all of our household equipments will be talking to each other, and same is the case with the production or the manufacturing sector. Our machines will be talking to each other. Your transformer will be talking with your protection relays. Your protection relays will be talking to your cable load information. Everything will be talking to each other, right? So once these things will start talking, how they talk is based on the internet. Now the good news here is the internet is a stable and well proven technology which is being used in industry, I mean in day-to-day life. So certain standards are already laid down. We can bank on that. We are banking on that actually. So we use these standards for delivering solutions for your plant, for protection, for reducing the cost of energy, for increasing the productivity, everything. So they will be talking to each other. So the open architecture is very important. So if you deploy one solution, and certainly, I mean, you want to have another solution from another manufacturer, so the interoperability between the solutions has to be maintained. For that, the open architecture is very important. Uh, because if, for example, if we provide some solution, if it cannot be integrated with your existing ERP, it's of no use, right? I mean, we are getting collecting data, and then from using Excel sheet transfer or through pen drive, if you are transferring. So the purpose of data collection is defeated. So there are certain formats of data export, Web API, JSON, and XML. These are open standards. So the solution is based on these open standards and how we can provide data in real time. So the biggest challenge with industrial IoT is the security. Now we implemented all of these things. We are getting our production data, we are getting our energy data, we are getting everything. Now we have provided that information through cloud. Our employee can access, he can attend the call as and when it happens. But what about the security? We have seen that, I mean, everybody is so concerned about the security of data, because this data is very, very important for your business, and for your plant security as well. So from external threats, I mean, there are two type of threats. Once we are exposing our data through cloud or to your employees. So one source of threat is external threat, where data is there, your production data, your plant data is on the cloud. The external threats can be mitigated using this secure internet specifications. I mean, the best part here is there are many security standards are there for internet, like for example 128-bit encryption, secured connections, and so forth. There are various type of security measures are there. So if we use that, we can implement external threat, we can mitigate these external threats. The best part with this internet technology is that it's a stable, well-established technology. So entire manufacturing can be dependent on that. But there is another threat, which is internal threat. So for example, if I'm sharing my production information with my employee, of course, I mean, employee is part of my team, right? So, but with certain, if someone is of malign, intention, I don't want him to, let him share or access in a wrong way. So for that, there are various ways like IP and MAC based accesses. Like, I mean, you can make it sure that the data which you are providing through cloud, it will be accessed only to designated devices. So if you are providing, laptops to your employees, so they can get that information, and you can protect these laptops anyway for any access through USB or Ethernet port, so that the data cannot be transferred from there, or you can protect it for storing any information on your laptop. So because if it is a company provided laptop, you can put so many restriction, and along with that, if you are providing some access using the Mac based access, so only designated laptops, I mean, through using this designated laptops only, they can fetch the information. The virtual private network is another way of protecting. So you form a private network, so employee from anywhere in the world, he can get it access to the virtual private network between your company, your machines, and the cloud. And once he access into the VPN, he get access to all of that data. The third one is, I mean, that will protect the data from unwanted access. The third one is the audit trail. Even if someone access some data, if we make some changes to any of data within your process, so that audit trail allows that all the data, all the changes which are happening to be protected. One of, I mean, if anyone from pharma side, I mean, they can vouch that in pharma, there is a specification called CFR 21, which says in detail that how you can protect your data. So audit trail is a key component for protecting your data in a way that, of course, I mean, it has record of who has accessed that data on what date. right? So if there is any manipulation happened, or if there is any tampering with data, you will know how it was done and when it was done, right? And of course, the next level is the stringent password policy. Various type of password protection is there. Hardware keys are another thing which people are using. So through the hardware keys, you can get access to your software, the cloud information. So this is how it is implemented. I mean, this is a basic architecture. You have machines and the server. This server is could be an in-house server of the cloud, which has an access to your ERP. Again, this ERP or any third-party software, it can also be on the cloud. So there could be there is a possibility of integration from cloud to cloud, and from there we see that we have analytical engine. So what we are getting for data is, from the machine is just a raw data, but is the responsibility of the analytical engine, which will convert that data into the useful information. If you remember from the second slide, all is data. So from that data, what level of information we want to extract, right? So the best quality of information. So we get information about uh, say your total cost, breakdown information, productivity information, and predictive information, and any anomaly in your process. So for example, if the temperature of your boiler is increased beyond that, or certain process is throwing some exceptions. So all that anomaly will be detected and the alarms can be generated. So analytical engine is responsible for generating the reports as well as the alerts and alarms. On the floor side, we have this and-on displays from the server. We get that information. So this is something like the data is thrown from your machine, which goes to the server, converted into information, and will be sent back to your own uh, production line. So you get that information, so that we know this Toyota productivity system. This and-on is a very important key factor, so that all the employees or the line operators, they will know what their productivity is, and they can stick to the target. So, so these are some glimpse of like how it will look like. So, for example, in this real-time viewer, we see this status of each machine, the machine status, whether it's in running condition, or if it is green, that is running, or it's in breakdown condition. So, what is the efficiency of that machine? How much is the target? For example, here it shows this 4146 is the target, and how much is being achieved. What is the target? I mean, the percentage of the target is being achieved. What has been the efficiency of the machine? Everything will be viewed online. And another is like, I mean, you can schedule your production, so that that information about your, what is the target of today. It will go to your plant viewer, and there you can just see what level of target is being achieved. So the benefit of the entire this process is it eliminates manual inconsistent process of noting data in books. So we have already discussed that manual collection of data is prone to error and manipulation and inaccuracy in value and time format. The cloud accessibility access digitally. All the data will be collected from anywhere and can be accessed by anyone anytime. I mean, and instances of change in the utility cost factor. The cost factor is very important, and if we can also set benchmarking for the expenses. So for example, in certain manufacturing, we can benchmark the cost of the energy usage in terms of compressed air consumption, steam consumption, and the electricity consumption. All of these benchmarking can be done. And if we have two similar type of machine, I mean, for the same type of process, two different machine, we can compare the between these two machines, and we can take decision whether it is better to replace the machine with the new one, so that the return on investment will be recovered very soon. Uh, Observe how changes in the relevant driving factor impacts the efficiency. So once we start getting that information, we can observe how fast, for example, if we have some certain data, right, and many industries who are following Kaizen process, right? So if they are doing any Kaizen project, so they can analyze data before Kaizen and after Kaizen. So how much improvement is being there. So once you have this measurement automated way, so you will have more confidence on in your and any corrective action which you are taking. So this predictive maintenance is again, I mean, artificial intelligence. In case of artificial intelligence, what does it do is it collects information from different sensors and different processes, and of course, if there is any failure occurs, you have to tell at that certain time there was a breakdown because of this thing. So that in case of artificial intelligence, that system trains itself using that information. So if in future, if similar type of situation is going to happen, it will alert you that, boss, this is uh, going to be resulted into a breakdown, so please do a predictive maintenance. So so actually, I mean, the cost of energy and cost of anything, so instead of managing accepting it as a fixed cost, we can proactively work on the cost factor, and once we have all that information, we can work it out what is the factor which is costing us the most, and we can take better decision. So thank you. So now Q&A. So please let me just check. Okay, right. One question from Mr. Sushil Pujari. Please elaborate cost of quality. Cost of quality, Mr. Pujari, is, for example, if any plant is producing, I mean, if the turnover of the plant is, say, 100 CR, right? And if their rejection is 1%, the 1% of the total turnover is around 1 CR, right? Of course, I mean, you can say that, I mean, some of the part can be reused or anything, but that will again subject to the process, right? So if we could reduce the rejection by half, right? Say 0.5% of your total productivity. So the quality cost will be reduced by 50 lakhs. So the cost of quality is entirely like how much. I mean, this is the major cost which is calculated based on the turnover. But if you dig out the cost of manpower and everything, so that will also be added into the cost of quality. Okay, so Mr. Mr. Roy, Shubhrangshu Roy, please show examples. Can you please just tell me like what type of example you are looking for? Okay, Mr. Arvind Kumar K is asking, Industry 4.0 is already in existence. What new form should this take in industry in post-lockdown scenario? Actually, Mr. Arvind, the Industry 4.0 is already existing concept. There is no doubt about it. But this is a ripe time. I mean, when we have to go for this new form of industry revolution, because in the current scenario we will see, I mean, now the ROI calculation in Indian industry will not happen that I have a worker who is costing me 10,000 rupees. If you are giving a solution for 1 lakh rupees, I mean, the ROI will be very, far and all. So, but now the situation will be very different. The manpower scarcity will be there, and the quality will be something which we have to work on that, and the cost of, the your utility, we have to look for. And the of course, I mean, for example, in case of electrical energy, we just pay for electrical energy as and when the bill comes to us, right? I mean, we don't investigate further. So once we have all that information, I mean, there are so many studies which show that only by monitoring you can reduce the cost of power by 20%. This is a fact across the industries. There are some ISO standards, ISO 50001, which says that energy management system. This is a standard for energy management system. If you apply this energy management system in your plant, you can reduce the cost of power, as well as impact on the environment. So okay, so Mr. Harish says IoT is a concept. What are the components of IoT? IoT is Internet of Thing. I mean, uh, if we are talking about this concept of IoT, is like similar to like the smart thing. So we are having phones, right? I mean, the phone was same as 15 years back. It was able to do calling, SMS, and everything. But when we made this smartphone, it can do many other things. So, and same is the case with any, for example, this smart meter, which is an upcoming area in energy measurement, energy industry. So how the things are made smart is when they start communicating. As I gave an example of a smart band. So the moment you wear the band, I mean, the body starts generating data. So so IoT, I mean, it's the same thing, the same sensor, but if it starts communicating with your system or your process, it will become smart, and it will become an IoT enabled. So the key thing of any of IoT is the communication, as well as some. I mean, there are various things. I mean, in IoT there are three ways. One is the communication, and there is some kind of decision or the analytics. So that is called edge type of IoT, where each node is also capable of calculating certain information. Okay, so I hope that answers you, Harish. Okay, also Mr. Keshav Bhatia also give guide. What will you be your take on a medium type industry who can work with full productivity, less manpower? And yeah, Mr. Bhatia, definitely I would love to be in touch with you offline. We can discuss. I need to understand what industry you are in, and we will discuss in length and detail. So let me just check if I'm missing any. Okay, one question here is Mr. Prashant Pandey. How the employee cost will be reduced if we install IoT and online monitoring system? Uh, I mean, that is very much subjective, Mr. Pandey. The cost of employee is not the cost of employee per se. When we are talking about the cost of employee is about the productivity. If 10 employees were producing say 100 pieces, if we can make them produce 110 pieces, the cost of employee per piece of piece product produced will be reduced. So we are not talking about reducing the employee by replacing it. I mean, of course, that could also be possible, but we are not talking about that thing right now. What we are talking about is increasing the productivity, and at the same time, if we can reduce the cost of rejection, the cost of, I mean, if we have more of employees and make them aware about the cost of rejection and the quality, the type of quality failure we are getting, So it's an, then they will be more informed, and they will produce with more attention, and with more detail. So if we can reduce the cost of rejection and increase the productivity, the cost of employee cost will be reduced. Okay, Mr. Murugan asked for, please show some example of SPC chart. Right now, I don't have that available on this system. I can share the SPC charts. This statistical process charts are key charts when we are talking about the quality and process parameters. I can share offline, or if anybody wants any detailed information in any of the concepts which we have discussed, we are happy to share with you all. So, so, one information. This webinar, we have a recording of this, and our technical person, the support system will be there. So if you have any further question, we can take it offline, or we are happy to help you out. Right. So is there any other question? Please do. We'll be there for another 2 minutes, and then we'll be uh, wrapping it up. So in next webinar, when we may talk, we may take some quality. I mean, I can see there are lots and lots of questions about quality. We will be arranging a webinar where we'll be talking about the traceability, the end of line testing, automated end of line testing, and quality parameter analysis, like statistical process. Some will touch base with something related to Six Sigma processes and how we can automate the testing process. So, some 27, 28. Okay. Okay. Mr. Murugan will give you an example for this is access to this system, and we'll share with you the complete system detail. Right. So thank you, everyone. Thanks for your time. I hope I could give some value to you. Please do share your feedback, and if there's any information which you want to, which you want us to elaborate more, please do share with us. Thank you so much. Thanks for attending.